everyone. Before I give up my presentation, let's take a look at this picture. What is the similarity of these pictures? Do you know? Green. Yeah, yes, they are all green in color. In the dictionary, green can mean means green color, but instead of this, green means something environmental friendly. I'm sure you may have heard of an organization called Green Power, which is an organization who care about the environment. But today, what I want to talk about is not about this organization, but a kind of subject you may now study. What you can see the word is tribe. Do you know what is added before is tribe?
Chem.
Yes, chem is tribe, chemistry. When we link up the chemistry and the green words, it comes to the green chemistry. If I don't talk about the definition of green means the environmental friendly, you may think that green chemistry is just dyeing the hair with the green color. Okay. However, green chemistry itself is a big topic. To be more specific, we can talk instead of principle, history, or development. We would like to talk about the application of green chemistry. And finally, we choose to present the synthesis of painkiller using the principle of green chemistry. You may ask, why do we choose this topic to present? And here are the reasons. First, there are many branches, as we are chemistry students, there are many branches in chemistry, such as biochemistry, inorganic chemistry, or physical chemistry. And we would like to link up the chemistry with environmental protection, as this is a serious topic nowadays. Because as the climate has changed a lot during the past 50 years, the polar regions start to melt, which makes the water level raise a lot. It will cause flooding in the lower area. And therefore, we talk about the green chemistry as it stress on sustainable development of the environment, which is fulfill our requirement. And we want to change the misconception of the general public that the chemistry industry will only emit the pollution and did nothing to save the environment. However, it is wrong. Actually, the chemist has done a lot to reduce the emission of pollutant from industrial process. And all these are green chemistry. Then why do we talk about the painkillers? It is because it is very common. We can easily buy it from the convenience store, from supermarket, or even or other else. I think talking something related to us can easily gain interest from the public. And finally, green chemistry is the major development in the future because it is the major direction for the development. Okay, now let's talk something in more detail. First, we will talk about the new synthetic method for the ibuprofen by the Boost company. This is a very common painkillers. You can see there is the old method and new method on the slide. Even you are not too familiar with the chemistry, it is easier to understand that if the reaction contains less step, the percentage yield will be higher and the reaction rate will be faster. And actually, this is based on the principle of atom economy. Atom economy describes the conversion efficiency of a chemical process in terms of all atoms involved. In an ideal case, the chemical process, the amount of starting material or reactant should equal the same amount of all product generated and no atom is wasted. You can see that. You can see that there are many brown atoms on the old method. That means those are wasted, and there's only a small part brown atoms. The second topic I would like to talk about is using the green, efficient, and recyclable solid and catalyst for the synthesis of S-green. In the past, in the synthetic method of S-green, we use the salicylic acid we gain from the guano bark, which is a kind of tree, react with acetic anhydride in the catalyst, and we generate the acetyl salicylic acid, which is aspirin and acetic acid. Traditionally, the catalyst used is concentrated sulfuric acid. However, this acid is environmental unfriendly because this is very corrosive. So we use the new polyiacid for the catalyst. This is a strong acid composed of the anion and proton, which used to replace the environmentally harmful lactic acid catalyst, such as the concentrated sulfuric acid I mentioned above. And this compound catalyzes the reaction more effectively than the conventional protonic acid. And you can see that the percentage yield and the waste is much faster than the previous one. And thirdly, I will introduce using the microwave radiation for the synthesis of aspirin. And you can see that using the microwave radiation for the synthesis of aspirin can prevent the use of the catalyst because it can save the chemicals, and as the catalyst used is something environmental non-friendly. If we use the microwave radiation instead, it can save chemical and is good for the environment. And it proved that the microwave heating is more effective than the previous case, as its use is the reaction is under solvent-free condition, which not require the recrystallization process, which can increase the percentage yield. We can see that the percentage yield is even higher than other cases. After talking so much detail in our topic, let's talk about how we can get the information from the article. And here are the 5 articles we summarized. And you can see that the published year is quite updated. 2 are from 2007 and 1 from 2006. And this topic covered different aspects in the green chemistry. The reason of using this article because they are suitable to introduce what is green chemistry to general public, and the articles are full of reference, easier to convincing people. And finally, the articles are updated, so just mention about 2 of them are from 2007. And this is the end of my presentation. Thank you.